The heater control valve regulates the flow of hot engine coolant to your vehicle's heater core, which warms the cabin. It acts like a gate, opening to allow coolant flow for heat and closing to restrict it. In modern vehicles post-2010, electronic actuators and sensors often control the valve, offering more precise temperature management compared to older vacuum-operated systems. The most common symptom of a failing heater control valve is a lack of heat inside the car. This happens when the valve is stuck closed, preventing hot coolant from reaching the heater core. This is especially noticeable during cold starts, leading to icy windows and an uncomfortable driving experience. Check this symptom first when troubleshooting heating issues. A faulty heater control valve can develop cracks or seal failures, causing coolant leaks. These leaks often appear as coolant puddles under the vehicle or in the engine bay. Look for coolant puddles under the vehicle or in the engine bay. These puddles indicate a leaking heater control valve. Low coolant levels due to a leaking HCV can lead to engine overheating. Monitor your coolant levels regularly. Promptly address any coolant leaks to prevent more serious engine damage. Ignoring leaks can cause overheating and costly repairs. Leaks account for around 40% of HCV-related issues, making them one of the most common symptoms. A failing heater control valve can cause erratic temperature changes inside the cabin. The valve may fail to maintain a steady position, resulting in sudden blasts of hot or cold air. This symptom is often linked to broader HVAC malfunctions, such as inconsistent blower speeds. Digital diagnostics tools like OBD2 scanners can often pinpoint the issue by detecting valve faults. Real-world examples show how HCV failures affect different vehicle models. In Ford F-150 trucks from 1999 to 2003, vacuum-operated valves often failed, causing no cabin heat, especially in cold weather. Owners frequently reported coolant leaks and temperature swings. BMW 3 Series models from 2006 to 2011 experienced electronic HCV failures, leading to erratic cabin heating and coolant leaks from corroded solenoids. These issues were particularly common in vehicles with high mileage. General Motors trucks, like the Silverado and Sierra from 2007 to 2013, had widespread complaints of coolant leaks and loss of cabin heat due to HCV failures. These problems typically occurred after 150,000 miles, with plastic parts degrading in harsh conditions. DIY fixes and diagnostics for heater control valves are increasingly accessible. Online resources like YouTube tutorials make it easier to learn basic troubleshooting. You can test the valve yourself using smartphone apps designed for automotive diagnostics or a multimeter to check electrical connections. Remember to always consult the manufacturer's manual or a certified mechanic for complex diagnostics and repairs to avoid safety risks. Proactive maintenance, such as checking the valve during regular coolant flushes, can help prevent failures before they occur. With the rise of electric vehicles, heater control valves are becoming less common. EVs use electric heaters or heat pumps instead of engine coolant for cabin heating. Experts predict HCVs will be obsolete in new ICE cars by 2035-2040 due to regulations pushing for hybrids and EVs. However, demand for HCV repairs will persist in older legacy ICE vehicles. The Tesla Model Y serves as an example of EVs not using HCVs, but heat pump issues can mimic similar symptoms. The future of HCVs reflects the shift to electric vehicles and sustainable technology.